Good afternoon, everyone, and welcome to the EGUG Birds of a Feather webinar series. My name is Joe Johnson, and I'm with Esri here in Redlands, California. Today's webinar will feature guest speaker and past president Kirk Tyler from Sulphur Springs Valley Electric Cooperative. He will be sharing his insights on how his company is using high-accuracy GPS for data collections. Before we get started, I'd like to go over a few housekeeping items. I'll then turn it over to our EGUG president, Jessica Vieira Atwell. On this slide, you'll see the different options you have during the webinar. You can change how you connect to the audio or adjust your view. Also, keep in mind you can ask questions during the webinar using the question dialog box and hitting the send button. Remember, there will be time for questions and answers towards the end of this webinar. Today's webinar is being recorded and will be posted on our EGUG page on GeoNet in about 1 week. You'll receive an email notice once it's available. With that, I'd like to go ahead and turn it over to Jessica.
Good afternoon, everyone. I just wanted to give everyone a few reminders. The Esri User Conference is coming up and is fastly approaching. The Electric and Gas User Group community activities will begin on Tuesday with our kickoff meeting at 8:30, followed by community luncheon from 12 to 1, and then our Birds of a Feather groups will be meeting from 4:30 to 5:30 p.m. Following the Birds of a Feather group meetings will be the community social from 5:30 to 7. So please come out and join us if you're going to be at UC this year. As well, Esri, our EGUG Connects 2017 registration is now open. It will be at the Chicago Hilton from September 5th through the 8th. This year it's a little bit earlier than normal, but we gave you kind of an extra day to wiggle with travel since it's over the holiday weekend. There's still time to submit papers through June the 9th. We're still anxiously awaiting determining who will be presenting for EGUG Connects 2017, and we're looking forward to the additional paper submissions that may come in. Again, excuse me, again, the early bird registration is open through June the 30th. And with that, I will be handing it over to Kirk Tyler to talk with us about ArcGIS Collector and high accuracy GPS data collection. Kurt?
Great. Well, thanks, Jessica. And I'm going to show my screen here, and I'm going to hit play on the presentation. Hope everyone can hear me okay. We have a project that required us to really think about speed and accuracy, and so we thought very quickly about how we could get going, how we could get up and running very quickly. And it turned out the collector for ArcGIS with high accuracy GPS is relatively new technology in terms of the version that's been released by Esri. And high accuracy GPS has come a long way too, and so we thought this would be a good project to get started with. A little bit about Sulphur Springs Valley Electric Cooperative. You see there the state of Arizona, and on the lower right corner, there's where our service territory is. That's about 5,600 square miles, so parts of our territory are extremely rural, and a lot of, but some of it is very urban too. So, and just for reference point, Arizona is kind of a big state. That's about the size of Connecticut there. So we have potentially a lot of landscape that we have to cover, and it's very mountainous as well, which leads to a lot of challenges with terrain and other issues of communication when you're trying to collect high quality data. Our project here, without getting into too much detail on the project, because this presentation is about high accuracy GPS and the collection required, this project was really about inventorying a specific substation and really improving all the asset records related to that. So the poles, the underground equipment, the vaults, the service meters, all of those things have asset information that we really needed to update in this particular instance. Our data was suspect in many ways. and we didn't have enough metadata to know what was right or wrong. And so we just said, you know what, let's get the whole thing. We had new formulas that tie maintenance expenses to plant value, and so we needed to be able to utilize that for this particular area. And we needed vintage on every single asset, which is a challenge because this particular system dates back a ways, you know, to 1957 or so. And we needed to eliminate map errors. We had missing facilities. We knew we had missing facilities in this area, at least in a few instances. And our location data was a little weird. So part of that was updating location of 7,600 facilities with high accuracy GPS. And this started in January. And we had to complete by June 30th. And so I'm just going to point out to everyone that it's not June 30th yet. So this project is still going, although the GPS piece of it is pretty well done. There were some realizations that we made very quickly after the first meetings of these projects. Accuracy and speed were super important to collecting this data. The deliverable is a table of asset records. Think of it as a giant spreadsheet that has to come out of geospatial data, right? The GIS has to be updated before we can deliver that table of asset records, because our conductor line footages, if you're in the utility business, there's some people here probably not in utility business, but those line features have our asset data too, and so those had to be correctly mapped in order to export their asset correctly. Shocker, internal labor only. We did not have time to spool up and tap into should we have a vendor or not help us with this project. And starting in January, we figured we could start in a month, and that would give us 3 months for field data collection and 2 months for GIS processing. Fortunately, both of those two latter categories got a little bit faster on us, so that's good. With a project like this, that is a must complete. It is a must do. The technology has to be there every single day. We wanted to learn from this project. These technologies, what methods and technologies can we take from this aspect and apply it to the rest of our system? And I like to think about this as a technologist, as a futurologist myself. Let's talk about mobile first. This is, maybe we're talking about a mobile app and using cloud services and data plans from Verizon. And Collector can be configured for fast data collection. The values for mobile first are about stability, scalability, and user independence. And user independence is really key. And let me give you an example of that. If I have multiple field data collectors and I need them to be independently making a decision, has this feature, map feature, been collected or inspected? And they need to be able to see on the map that, oh, those facilities over there were inspected by my colleague yesterday or even today, but I can still collect these. And so they can work independently of each other without a lot of overhead of coordination. GIS updates also requires conflation of facilities to do locations. So updating all these facilities, we have points and we have lines, and we're just emphasizing the points in the data collection side because that's what Collector is very good at. But the lines also have to all be moved, which is pretty challenging. And I've come up with some geoprocessing style tasks to do that. That's out of scope for this presentation, but it's required for a project like this. And overall project steps, let's assume we have to visit every known site. We don't know what we don't know. That's ultimately what it comes down to. So we mapped, we presented that information, we had to review construction units and asset accounting, all this work, all these words on this screen here. In the middle it says perform field data collection. It's underlined. And I have the picture of the iceberg here because that's the perform field data collection. That's the piece that everyone can see. That's the boots on the ground. That's the top of the iceberg. But the bottom of the iceberg is all that other stuff that just has to be done. So, and I'm going to flip around the iceberg thing, and we always think of icebergs and Titanic and all this bad stuff that happens with ships. But the more work you do below the water line, the more work you do in terms of creating a good data model and having good hardware and software, the easier the top line piece is. And ultimately, if you have a good data collection process, your guys in the field are fast and efficient and not having to recreate the wheel and figure out a lot of problems. So we wanted to make that top of the waterline piece as small as possible because that's where a lot of labor is, frankly. And when we're done, we have to finalize all these asset reports and get them to our accounting groups. When we started our data collection, I pulled up this picture because I started thinking about the real world. We have a lot of assets we want to collect. We want to collect a pole, but a pole isn't enough. We need to know if there's cross arms on that pole. We need to know if there's transformers and if there are secondary voltage supports and down guys and anchors and all that kind of stuff. And these particular things are all assets, and we have a library of construction units that needed to be collected. And when I did the math, there were, I think, of this top level categorization, there were 87 different combinations of assets that we could be collecting. 87 different combinations. And so one data form wasn't going to hold the data. So what we ended up with was a generic feature called an overhead point, which is a pole. And every pole has some information on it. And the Esri app also stores metadata about the data collection and the editing and the GPS locations. But the combinations, those got punted into related tables. And it turns out that that's a very flexible mechanism. So my transformer can have transformer-specific fields. My down guys and anchors can have very specific fields. So, and you can, with related records, you can do one-to-many records. And so that turned into the data model consideration, and I'll show you that a little bit. Choosing collector, there's many apps to choose from in the world. You know, you can roll your own if you really wanted to. But really, this one was about getting up and running fast for me, and it was about ultimately about enabling the field worker. I wanted to be able to create and share a map and very quickly and within minutes get up and running. If I make a change to a map, there's a lot of iterative processes there. We want to publish and control the data. I want the app to reflect my data. For all those GIS people in the room today, it's your data, your life, sometimes your job. So you want to make sure that data is really good quality for you. And it wants to be configurable. It wants to be configurable to the environment you're using. It also has to support really important field workflows. I needed these guys to be able to work independently of company infrastructure. That's not a slam on company infrastructure, but it is a point that there's some overhead in terms of being able to having someone in the office when something goes wrong. In this case, this scenario, these guys could have gotten up, left their house and gone straight to work if we were set up to do that. So I thought that was really interesting that we could do that. We can be offline and disconnected. Offline meaning not live connected to the internet, and we can have that data stored locally. GIS experts are not needed to do high accuracy GPS. This is pretty key, and this is a huge shift in technology. And it's important because in the old days, we would have to collect that data in the field, bring it back, download it, and then do a post-processing on that GPS data to get high-quality data, and then convert it into some shapefile thing, and then bring it over to Esri environment. A lot of GIS-heavy things. Now we're just going straight to the cloud with that data. The data's there, and it has some belief values that I really like, which is I want my people to be experts in the field, and good software and hardware gets out of the way of the user. There's a lot of work we had to do in the beginning. I just highlight this as some GIS work, but we moved our data out of production, this one area. We published a simplified version to ArcGIS Online, so we did use Esri's cloud service. You could use Portal, that's fine too. We created those forms in Collector, creating the data models, support that. We had to connect that high accuracy GPS to understand how Collector works with it. And you know, really you're going to iterate several times on this, but you can do this very quickly. Within a week, you can iterate a dozen, 24 times. And so it's very quickly you start to get the feel for how the whole thing really works. And I'm going to talk a little bit more about the GPS side. Our field software and hardware solutions, we had 2 field data collectors, 2 individuals there. They are linemen, so they have all the background in terms of how power facilities are built. And they're familiar with the library of construction units that we typically have. We used iPad Mini 4s. We chose the EOS Aero Gold GPS hardware. And Atom Field Solutions was very good to us. We purchased one, we rented one, so that was easier on our budget. And really it came down to cost, ease of use, and known configurations. So could we guarantee that this project would succeed? Well, this stuff all has to work every day. We use Collector for ArcGIS, and then we have the EOS Tools Pro, which is an app that works with the EOS GPS unit, and it allows us to connect to the Arizona RTK network, and that's where we're getting our high accuracy GPS corrections from. We also use iTunes. This was kind of one of those little things, and I just throw this out here. Collector for ArcGIS allows one base map to be downloaded. Again, we were disconnected in the field, and we wanted those aerial photos in there, but we also needed a street. And so our analyst, David Johnson, created a TPK package that we could sideload in iTunes, and it was available on the app. So that worked out really well. We also make sure that we had local backups. If one of our users goes down, could we go to the store, buy this commercial hardware off the shelf at Best Buy or something like that, and be up and running in a day? Yeah, you bet we can. So we've disconnected the hardware from the GPS, the software from the hardware, and it all has sort of this best of breed capability, but because it interacts really well as a system, it's all very reasonable. Here you can see the iPad Mini 4. It was chosen for its size and its weight because it's expected to be carried all day. I have that case with the handle straps. You can see it's pretty easy to hold your hand in it. You don't have to have a strap around your neck or anything. The GPS receiver in the center of the picture there is the brains of the whole show there with GPS, and it is very holdable, very lightweight. I was impressed with how far the technology has come. And then it's tethered with a little cable up to an antenna, and you see the antenna there. It has the puck and then a wider metal base plate. The whole thing can be mounted on a pole. So our guys chose backpacks ultimately because they wanted to carry some other things with them. So we had a little pole on the backpack that they could screw that onto, and they would hold it up above their shoulder. But you could conceivably take that base plate off and put it in a hat, and then put the GPS unit in a little hip holster or something like that. So that all worked fairly well, and then it's Bluetooth from the receiver to the iPad, and so that's the whole package there. I wanted to talk a little bit about running high accuracy GPS on these tablets and how kind of this works. And this isn't going to give you all the nuts and bolts of the details here, but basically your GPS receiver on the left is receiving GPS signals, right? And over on the right you have a base station, and that base station is receiving the same GPS signals from the same GPS satellites, except the base station knows exactly where it is. And so it is sending out a correction to say, this is where the GPS thinks it is, and this is where I know I am, and this is the correction. And it's a directional distance kind of thing. So if it's 3 meters or 1.8 meters or whatever that distance is, it's going to send that correction. The EOS Tools Pro app receives that data. So it is communicating with the RTK network. It's receiving that data over the internet. It sends the correction to the receiver, and the receiver does the math. So the receiver does the math in real time and decides how to make that correction. EOS Tools Pro receives the corrected GPS signal on Bluetooth back from the receiver, and it sends it over to Collector. So Collector, its only job in this particular case is to really receive that NEMA stream, right? And it's looking for the receiver, it performs a geographic transformation, and it prioritizes over the native GPS signals. So in iOS, for instance, iOS only reports down to 5 meters of accuracy. So you could have a high quality GPS signal, but you would never know what its accuracy level is. And we found that frequently, and in these phones and everything, it's using assisted GPS, AGPS, and AGPS is notoriously bad. 300 feet. It's not uncommon to see 300 feet out of that. And that changes second to second. So it looks good and the map looks good, but it may not be all that great. So I'm going to do a little app demo for you. I've done this demo about 6 times, and 3 of the times the technology didn't work. And I didn't want a funny little notification coming in on the phone while I was using it. You know, hey, how'd your webinar go today? So what I've done here is I've recorded it. And so we're going to flip over to the video. And I hope everyone can see the phone there today. I've opened the EOS Tools Pro app here, and we can see our position data coming in from the GPS unit. And on our position screen, we can see in the center, it says HRMS. That's horizontal root mean squared of accuracy. This is shortly after it's been corrected, but that's in meters. On the satellite screen, we can see the different constellations that are available to us. And some constellations it's future-proofed with Galileo and Beidou, and a little map view to tell us where we are. And so this is great information. It used to be a real problem, be able to see this stuff. And on the position screen, a little bit more detail, alarms, very easy to see what's going on if we got a problem. And this is where we're going to connect to the RTK network. And we can see the caster, the IP address. That's really just the server that we're connecting to. And these are the various mount points. These are base stations. And so this one is Pima RTCM 31. That's Pima Community College in Tucson. And here is the terminal application receiving that text stream of GPS signals. And we can see on the colored lights on the top right, green and red, that we are transmitting and receiving the data the way we should be. They've also included a little web browser in there, so do we have internet connection? Great for troubleshooting. We can see now that the accuracy comes in, and now we're at 2 centimeters. And it is reporting ellipsoid height. In the future, I think they're going to support mean sea level, which will be very useful for data collection. Okay, let's go into collector. First thing we have to do is we have to connect collector to the GPS unit. We're going to go into settings. And under the location piece here, where it says provider, we're going to look at that provider, and that's my GPS unit that's connected over Bluetooth. And it's really easy. I have the antenna height set to 2 meters. And then the location profile is where we set the data, the GPS corrections. So here I have the receiver coordinate system. It's very important to get this right. The map coordinate system, we're using base maps, so we're using the Web Mercator map system. And the datum transformation, because the data is going to be stored in NAT83. So all of these things are super important to get right, and they're not incredibly well documented, so that's a piece you need to look at. Let's go into the app. We can see that on the map here, I turn on the GPS, and now I'm at 3 centimeter location, and I can see an asset nearby that I'm going to do some field inspection on. Before I do that, though, I want to see if I can, what kind of data am I seeing if I select that overhead point. But here is that's what collector is reading for the GPS correction data. And on the overhead point here, we're going to edit this guy, and we're going to change some data about it. So I'm going to add, here are my construction units for the type of pole it is, and I'm going to put some, I have some grounding, and I could add a photograph, and I'm going to put in that year for the vintage, because that's part of our project definition. And I have relatively little data on this particular point, but I am going to update the location, and what's going to happen is we're going to hit update, and it's going to send that to the server, and now it's moved it underneath my GPS point. So if I take the GPS off, you can see it's underneath there. Some other things I want to do as part of my data collection project is I need to collect some related data. And the related data, I'm going to step back out. I'm going to go back in. I'm going to select it. And we're going to pull up, here's our related data. So these are the related tables that I need to collect on for my field inventory. And I'm going to put in a guy anchor. Again, these are domain values in the Esri system. And so we're going to choose our quantity, put in the number of anchors. And these attributes are defined on the table level. And so we can make some very good attributes. If I think I need to add a transformer at this location, so I'm going to add in a transformer. And so here I'm going to have values that are specific to this inventory project. KVA values for that transformer, and the secondary voltage for 12240. There we go, and my construction unit for that transformer. So when I'm done, I have a related table with all of my overhead transformers in it. So it makes reporting on the back end real easy. And now I have all my data selected. And I think at this point I've collected the data that I want to collect. And I'm going to look at an area of our area where we collected information, because I want to show you some things about how accuracy changes what you're looking at. And in this particular instance, we have a meter service at the end of the line here, and I'm going to measure that so I can show on the screen the line where the service at the end used to be and where it is now. And so we see where it used to be, it's 45 feet away. The transformer that is nearby has also been shifted off of that line. In the electric business with geometric networks, we're all about connectivity, and that's moved almost 12 feet. And we can see out at the end that there's a vault that's also moved a little bit. And this line will look different when the project's all over. It'll look more like this. And that's a big difference when you're shifting thousands and thousands of facilities. And that's just for this one substation. So there's a lot of work that goes into it, but that accuracy really does matter, and it makes all the reporting around this for this project go a lot better. So I'm pretty happy with the data we're collecting. Here's a transformer that's been collected. We can attach photos and all that fun business, so you can prove that it's there. And collecting additional information. So you can, and so the system, the app, has worked rather well. It's been a very robust tool. There's been about, I think there were only on the entire project about 3 days of actual failures. And one of those failures was the Amazon outage when ArcGIS Online went down as part of that. You probably remember that a couple months ago. The second one was our RTK network in Arizona had a bad day. And I think we had some other small issues too. So from a reliability standpoint, it definitely worked. From a scalability standpoint, what did we find? We were able to inspect over almost 8,000 facilities. We've collected 34,000 asset records in that timeline with this data form. And there were only about 32 days of actual data collection. We had some cleanup days. You always have some cleanup days. And our average locations per day were 235. So we had 2 collectors, so you could say on average about 115, 117 points a day. But really that doesn't tell the story, because the first few days were really about training, and there were some other issues that came up. And so, you know, there were days when they were rolling in the middle. There's a bell curve to these projects. In the middle, they were collecting over 600 points per day. So these apps were reliable all day, each person collecting over 300 locations per day. So productivity is proven to me, scalability is proven, and certainly reliability. Let's talk about location accuracy. Median accuracy per location is 4.6 centimeters. So half of the locations had better, half had worse. Our median distance from old locations to new was 5 feet. So half of these locations were less than 5 feet. Half of them were more. And really from a standard deviation point of view, probably most everything fell within 30 feet or so. So that's not terrible. Some utilities have different standards for that. But when some of your facilities are 345 feet away in the maximum distance here, you don't know which value to trust. And so a baseline with good quality GPS data helps you understand where you are. I do want to point out something about the accuracy, median accuracy per location. We could sit there and really dial it in to get down to 2 centimeters pretty reliably. That's not a problem, but we were concerned about speed. So if we had some spots where there was bad location data, for whatever reason, we decided to move on. And so that's where some of these accuracies change. Also, our base station that I'm connecting to could be 70, 80 miles away. We don't have a base station within the recommended 40 kilometers distance. And the farther away your base station is, the more those corrections have a problem. And most of the time, I think most of the time we were getting in the 2 centimeter range. And I was more than happy with that. Your vertical is going to be approximately double that, so about 4 centimeters. That's great. That's perfect. Without that, probably about 12 feet. Without this RTK network, you couldn't really guarantee better than 12 feet. They always say sub-meter, they always say this and that. But a lot of our facilities were not in the right spots, and you don't know what data to trust. And so this gives you that trust circle really dials in, and it really comes down to a nice spot. So some things that we learned about this, the GPS and the networks are much more reliable. Linemen can run high accuracy GPS. They can be trained, the tools are there. They have all this field knowledge. They're a little more expensive than a 20-year-old data collector kid that you hire off the street. But they can run, these experts in the field can also run high accuracy GPS. Keep prototyping, keep iterating until it's right. We could have iterated 1 or 2 more times and it would have been good. But at that point we were in production and they were rolling, so we decided to keep moving with it. I wish I had stored the original XY coordinates on the features. I used the original object ID from the database as an attribute on the field because I wanted to be able to track where it was and where it's going, and I just wish I had stored the original XY coordinates. Would have been simple. Collector for ArcGIS is configurable. You can limit field visibility and editability. Our map was entirely configured using the ArcGIS Online map viewer in the browser. So that's not hard. I mean, you can set field orders and you can make table aliases. And, you know, it's not super configurable, but it is configurable for the field user. And in the end, really, this high quality location and asset data, it's much less expensive than in the past. You can jump in with a unit for less than $10,000 and you're up and running. The RTK network, if your state has one, it's most likely free or low cost. And the services work reliably. So I've been really happy with this. A couple shout outs here. Some people not on this slide. First, last year in EGUG webinar, Dr. Comfort Manyame at Mid-South Synergy gave a presentation on using Collector for field inspections. Dax Wolfinger at IID took me aside one day at an EGUG conference and talked to me about Collector and talked about scalability and that sort of stuff. And there were some other people that gave me some ideas about data collection and some things like that. And Matt Alexander at Anatom Field Solutions, we didn't have to ask him a lot of questions about this, but when I did have some questions specifically about datum transformations, he was right there for me. So big shout out to him. And David Johnson, our GIS analyst, really helped in the trenches of getting this thing rolling and making sure this project was very smooth and supporting our field guys as needed. Once we got up and running and everything was flowing, really we didn't have to do a lot of field support. So it felt really good. So at this point, if anyone has any questions, I think Jessica's going to chime in and we're going to be able to ask some questions here at this point. So feel free to get into the question box there and tell us what you think.
Yeah, Kurt, I have one question. This is coming from Drew Taylor, did you need to supplement the power supply for the iPad Mini or the Aero? And if you did, how?
We didn't really need it for the Aero. It has an all-day battery, although we found that, so it's getting all these RTK corrections all the time, and that's extra math, and extra math requires extra battery. But we found out we could reliably go about 8 hours. And that is collecting hundreds of locations. If you're only collecting 50 points a day, you're not going to stress out those batteries on the GPS unit. The other side to that is the iPad. The iPad, you're running an app in the background using location services. You're running a constant data stream to the internet and the Bluetooth constant data stream, and the screen is always on. So yeah, we got an Anchor battery pack that you can, they would plug it in probably half the day. But what is that? 30, 40 bucks. That's pretty cheap to keep running all day, so that worked out really well.
Okay, another one from Joshua Thomas. Do you know of any testing that's been done, or did you do any testing on Android operating systems?
We didn't. My understanding is that the app works pretty much the same. So, you know, it does. My understanding from Esri is it does work the same. I'll leave it at that. We didn't go into that. I think some of the, you know, basically you can do the Bluetooth protocol. The EOS does work on that too. So it's, you know, that's all there. So I think it's your choice. You know, you want to take a look at that. There are some dedicated field units with that have Android in them. You know, you can look in sort of the, you know, they're not tough books, but they're sort of lightweight mobile tough things that you can use for field data collection, and some of those are on Android.
Were you or did you receive any pushback from internal IT or security about warehousing your data in a cloud environment, because you actually hosted the data on AGOL?
We hosted simplified data on AGOL. Okay, so I want to point that out. I didn't upload the entire database. I uploaded overhead points, underground points, and we collected certain data. About halfway through the project, we had a question about security. We opted to say that the project was well underway and it was high profile enough we couldn't go back on that part. At the time, we weren't quite ready to support our own portal instance due to some internal reconfigurations of our network, and so that kind of pushed us towards the AGOL. But I mean, certainly if you're concerned about security, you can use your own internal portal, and you can connect. You can have the guys do synchronization at the end of the day inside your office network over corporate Wi-Fi that's secured and everything else. So that's definitely a possibility. And to really, if we were to do this into real production, like all the time kind of thing, I think that's how we would do it. But as soon as we're done, you know, we downloaded the geodatabase off of AGOL, deleted the geodatabase from AGOL, and we're good to go.
Okay. Trey, are there any questions you'd like to ask?
I had one, just kind of thinking about some of this, Kurt. This seems like this might be a good project as we look towards utility network and redoing some of reanalyzing some of our system. I don't know what you had on your thoughts about some of that, Kurt.
Well, one of my slides I talked about mobile first, and mobile first to me means doing the work you need to do wherever you are. If you're in the office and you're doing desktop, that's great. But you should be able to perform a lot of your work on mobile, because that's where, if you're in the field, that's where the work is. And so the more we can do there in the field, the better off we are. I would love to have just connected to my live geodatabase, my production geodatabase, selected a feature, and said, this is where it actually is. That would have been great. That would have simplified so many things from a data processing point of view. But I didn't do that. I couldn't quite do that because the geometric network is still there. With the upcoming utility network that, you know, hopefully we're going to see a public beta here coming soon. And as Esri releases that into production, you know, I don't know when, the end of this year or something, or early next, whenever that comes out, my hope is that we'll be able to move to the utility network, and then an app like this can connect to it live, and I can synchronize those changes directly back to my production database, and then all the processing happens in one spot. So I don't have to go through that.
How well did these devices stand up to the heat in Arizona?
We were in the winter time, so you know, really we're in the high desert, so we're not particularly hot until June here. I mean, I think just yesterday it finally got to 95 or something. So we completed most of this project in the spring. I think the devices work rather well. I could see where the commercial grade hardware, like an iPad, you know, that's not industrial grade equipment. So in the heat of the summer, if you're in a hot zone like we are, that could be a problem, you know.
Now, Kurt, I know you mentioned that you're looking at incorporating the data back into your main system. I know you put there that it's hint, hint, wink, wink, that there's some geoprocessing going on. Would you like to give us maybe a brief intro on what you did without necessarily wading too deep, or what your plans are? I figure we may hear more about this at EGUG Connects, but is there there's quite a few questions about how you're reincorporating this data into your main enterprise. Since you had to split it out and piece it apart to be able to facilitate data collection, how are you now planning on incorporating that data and using it to update your actual production environment system?
Right. It's a real challenge. So earlier I mentioned, I don't know if I didn't speak to it, but I removed the geometric network from this local copy of the data, okay? Mm-hmm. And that's so that I could perform fast processing on this data. You know, frankly, just the editing speed really drops when you're working with the geometric network. And so I didn't want that overhead in the processing. It also allowed me to leverage more tools against it. I'm a big FME user, and so I built some tools that allow me to, if you have a line, let's say you have a span of, let's say you have 6 power poles, and you have a line connecting that has a vertex connecting to 6 poles, right? The trick is every vertex on every pole has to shift. And so there are some tools that I found that I can decompose a line into its vertexes, shift the vertexes from where it was, the vertices from where it was to where it is, and then rebuild the line in the exact order that it was made. It's pretty low-level stuff when it comes to this geometric transformation. It's either do that or hand edit all those things. And frankly, I just didn't have time to hand edit, and I could have farmed it out and, you know, to a contractor and all those things, or just done it for the next year. But we're talking about 10, you know, and this is hard to translate to your managers, but there are tens of thousands of these vertices that have to be managed. So some geoprocessing around that is super critical. Reincorporating it back into production means deleting the existing data and literally copying this data back in. There will be some relationships that have to be managed, and the data has to be managed, and that will come soon, I imagine, here in the next few weeks. So I'll let you know after the end of June 30th how that came out.
I can see this coming down the line where you're going to end up doing your entire system like this. This was the beginning of your very slippery slope, Kurt.
Yes, it is a slippery slope. Oh, that was easy. They got it.
Kurt, I had a couple of questions here. I have quite a few people here asking about the accuracy stuff. People asking about how either you know, tree cover or being near buildings or busy areas, how that might affect some of your accuracy. If you had any issues with accuracy and interference with some of the antennas.
Yeah, we definitely. There's some technology that I would like to be included in Collector, and I know that Ezra is looking at it, and that is being able to do an offset. So let me give you an example. You're standing in front of a building, and there's a meter mounted on a meter panel mounted on a building, but it's under a steep overhang. Standing next to that to get the exact location is impossible. I would love to be able to do an offset of, you know, 6 feet and at 89 degrees and have it automatically shift the location to that spot. In this case, I just had the guys stand back just a little bit and, you know, figure it out. A couple other animals on location accuracy. Tree cover, we didn't have too much of that problem. If you were in wet tree cover, that can be an issue. And then in some ways, that's where RTK really helps you, is because the cell phone signal can get to you and can help with that location. So in some ways, RTK is great because it can help you with that instance, where you're not relying solely on the quality of the data coming to you through wet leaves. If you're in a climate with wet leaves, that can be an issue. And one more thing on data quality. Different manufacturers will say, they always say, well, we've tested this and this is what it is. And we did some benchmark testing on our own with this device, and we found it within our acceptable accuracy standards. But different devices, if you tested them on the same benchmark, would report different accuracy, might report the same accuracy level, but actually physically put it in a different spot. So So we were okay with that accuracy. We did some benchmark testing, and I recommend anyone getting into this to learn some basics about benchmark testing so they can really dial that in and try to understand what they're working with.
All right, looks like we have time for maybe one more question, and I'm going to wind up here. With the EOS positioning app that you have, how easy did you find that to use for yourself, and then how would you say for a relatively novice user, what do you feel like their comfort level would be to ramping up this type of an environment, a production environment like you've done here with somewhat limited familiarity with RTK and post-processing, et cetera?
So the best way to think about this is to decompose it into different problems. Okay, collector works on its own without high accuracy GPS. So understand collector, figure that out, right? And then step over to high-end GPS, do some research, look up RTK, look up the N-trip protocol, so you learn a little bit how that works, about RTK systems and what that means. It's the same stuff that surveyors have been using for a long time. It's just leveraging the internet to get that done for you. The other thing is with whoever you're buying from should be able to provide you some customer support. And when they can do that for you effectively in a short order, you know you're talking to the right people. And so they can walk you through a lot of that. Now, the actual setup, I think the first time we powered it on, we just powered it onto our phones, and the Bluetooth picked it up and the app picked it up within about 2 minutes. So connecting wasn't a problem. The technology for that piece of that is pretty reliable. The RTK piece, we already had a good sense about how some of that worked in our state, so we had that knowledge. So there's different components that you want to educate yourself about. That part can take a little bit of time if you're starting from scratch. But from a ground-up setup, if you know these things, setting one unit up, and if you have everything kind of lined out, you can be up and running and with one unit on your on your device of choice in just a few minutes, really just about 30 to 45 minutes. You can have this thing running from scratch.
That's fantastic. All right, well, if there are no further questions, we have compiled a list of all the questions that came in, and we'll take some time to review these after the webinar. Kurt, if you'd like to hand
you bet.
Back. And I just want to take a moment to thank Kurt and Joe for helping us out today with our EGUG webinar. Kurt, that was a fantastic presentation, and again, I look forward to hearing a bit more about how you've post-processed this and all of your geoprocessing that you've done to incorporate all of this data back into your network data set. And with that, I am going to hand things back to Joe to close us out.
Thanks, Jessica, and thank you, Kurt, for that informative demo. That ends our webinar today. Remember that this has been recorded and will be available in about 1 week. So thank you everyone who attended, and have a great day.